Hello everyone, this is DSS Zindabad and today we are going to discuss the daily challenge of Leetcode, which is number of submatrices that sum to target. Let's jump into the problem statement. Given a matrix and a target, return the number of non-empty submatrices that sum to target. A submatrix x1, y1, x2, y2 is the set of all the cells matrix xy with x being less than equal to x1 and x being greater than equal to x1 and less than equal to x2 and y being greater than equal to y1 and less than equal to y2. Two submatrices x1 y1 x2 y2 and x1 dash y1 dash x2 dash y2 dash are different if they have some coordinate that is different, right? For example, x1 is not equal to x1 dash. Okay, so let's talk about how we will be solving this problem. First, when you go through this problem statement, you understand that you will be given something like a matrix, right? So basically, this matrix can have any value inside it, right? Suppose you had something like 1 minus 1 minus 1 1, right? So this is a 2D matrix that you initially have. Now, what you have to do is, alongside this 2D matrix, which is given as an input, you will also be given a target value. So basically, target will be something, it can be any number, right? So for example, for this test case, we have target as 0. So what I have to do is from this given matrix, right? I need to find the number of submatrices which have their sum equal to the target. So what is sum? Sum means the sum of all the elements in that particular matrix. Okay, so let's understand how do I mean it, and then we'll talk about what approach can be followed. So considering this matrix, I need a target as 0, right? So the first thing I can see is if I can take a matrix like 1 and minus 1, right? This is a matrix inside a matrix, right? So if I take this, I add these two numbers, that is 1 and minus 1, I'll get 0. So I can say that initially my count was 0, but as I found one sub-matrix inside the matrix which has the sum equal to target, I'll increment my count by 1. Now, the next thing I see it, if I take this one, that means the submatrix, which is starting from the first row, right? And is including both the 0th and the first column. Again, if you sum up the elements, you will get the target, right? So in that case, my counts get incremented. Now you can see one more thing, that if you take something like this, that means 1 and minus 1, right? That means if I'm taking the 0th column only and I'm considering both of the rows, 0 and first, right? So for that matrix also I will have a target that is equal to 0. So my count becomes 3. Similarly, if you look at for column 1, row 0, 1, this submatrix has also target equal to 0, so it becomes 4. Now, if you see the complete matrix that we had, right? So this complete matrix, if you add all of these numbers, you have 1 plus minus 1, that makes it 0, plus minus 1, now you have minus 1, plus 1, that makes it 0. So that is again equal to target. So basically from this one matrix that has been given to me in the input, I know that I can have 5 submatrices whose sum is equal to the target. And that was 1 minus 1, right? Minus 1, 1, 1, minus 1, and minus 1, 1. And the last one was which had all of these elements. So these are the possible number of matrices for which the sum will always be equal to the target. I hope the question is clear. Now let's talk about the approach. So when we talk about the approach, the brute force that comes into my brain is that if I could, from the given matrix, right? I have been given a matrix, right? So from the given matrix, if I can create all the possible submatrices, right? And after making these submatrices, I'll like store them in certain data structure. Then in that data structure, I'll traverse over them, figure out the sum of all the elements, and then finally, accordingly, like for example, if that is equal to the target, in that case, I will increment my answer variable, right? Or else I can go to the next submatrix that I have, right? So this is one approach of doing it, but it has a very high time complexity. Why? Because we are first creating all the possible matrices, right? A lot of them might not have their target sum equal to the target that we require, right? So, and then we are storing them in a data structure. Then we are retraversing that given sub matrix, right? So again, it can be linear, it can be 2D, right? It entirely depends, right? On the size of the matrix that was given to you. So it has a very, very high time complexity and space complexity. So I need to have an approach wherein I can decrease this time complexity and space complexity. So to do that, I will use something like, now I am discussing the better approach that can be used. So basically what I'll do is I'll use something like a prefix sum. I am pretty sure that a lot of you might have done the question wherein we have to find the number of subarrays which equal to k. It is on Leetcode, right? So basically in this question, what happens is you've been given a subarray. Sorry, you've been given an array, right? So for example, you had something like 1, 2, 3. And you have to tell the number of subarrays for which the sum is equal to 3. That means the k is equals to 3, right? So here what you can see is, you can see that you can consider that 1, but 1 is not equal to k, then you can consider 1 plus 2, this part. That means if you are considering the zeroth and the first element, so that is equal to k, right? So you can increment the count by 1. Then if you take all of it, here you see it becomes, it was already 3, 3 plus 3 makes it 6. So no, it will not be added. For the next thing, what you can do is, you initially started from here, right? And as we know that subarrays are continuous in nature. So you cannot delete elements while maintaining the order. You cannot do that. You have to take in a continuous fashion only. So now you will say that I just take 2. This is no, that is not equal. I'll take 2, 3. No, because it becomes 5 and it is greater than the sum. It is not exactly k. So you have already exhausted this. You will move forward and now you're standing on 3. So you will see that yes, 3 is equal to the sum. You will make the count to 2. So we'll be using the concept of this problem using prefix sum. So in prefix sum, what happens is, rather than recomputing things, what I do is, I say that let's have everything done in a very less time complexity, wherein I'll say, okay, whatever is the value of the previous column, you add it into the value of the current column, right? If you do that, for example, I'll tell you, for example, you had something like 1, 2, 3, right? So here it starts from here, right? From the first index, because I want to go to 0. I cannot start from 0, else when if I do a -1 for the index, then I'll go into a negative index and I'll get a runtime error, right? So here I'll say add whatever is your value plus whatever is your previous value. So it makes it 3. You move forward, you say add whatever is your value and the previous value, make it 6. So now you know that if you are just standing on the 0th index, you will have a sum that is 1. If you are standing on the first index, that means you will get a value which is the sum of value of I minus 1 plus I, right? That means in this case, the sum of zeroth index and 1. So that is 3. Similarly, if you are standing on the second index, you'll get the sum from 0 to 2. That means you have 0 plus 1 plus 2. These are the indexes. So whatever is present on these indexes, their sum you will have in this block. So this is how we use prefix sum. I hope this is clear, right? So now let's talk about what algorithm can we use so that we can boil down the time and the space complexity. So basically what you can do is, for the purpose of an algorithm, I can say that if somehow I can compute the prefix sum of each row, and as I told you, what is the prefix sum? Prefix sum is when I am adding the value of previous column into the value of the current column, right? As I just showed you in the example. The other thing that I'll be doing is I'll be creating something like a map. So create a map to store the count, right? So basically what we'll do is we'll create a map to store the count of the prefix sum. That means from one index, that example I is equals to 2 to I is equals to 5, right? You got a particular sum value, right? You'll store it in your map and you'll know how many times is this sum value repeating, so that you can directly, from using a map in O of one time, you can give me its frequency. The third thing that I'll do is, see, if you talk about an array, right, it is very different. Why is it different? So if you talk about an array, it is very different. Why? Because it is one dimensional, right? So herein you just have to consider a one row only and you can have multiple columns. But when you talk about a two-dimensional matrix that has been given to you, so you have to consider, in this case, what you have to do is, in the case of a, sorry, yeah. So in the case of a 2D matrix, what you have to do is, you have to maintain the range for rows and the range for columns also. That means if I was given something like a 3 cross 3 matrix, right? I have drawn it here, right? So there can be different submatrices corresponding to it. You can have something like just 0, 0. You can have 0, 0, 1. That means you're considering just the 0th row and the 2 columns. Or you are considering all the 3 columns and the 0th row. Or you can have something like you're considering 0 and 1th row, but only the 0th column, 0th and 1th row, and 0th column and the first column, and so on. Different combinations can be built, right? So what we'll do is, we'll say we need to loop over all the possible submatrix combinations. So this is what I'll be doing, right? Using the concept of prefix sum in that question of finding the number of subarrays which have a sum equal to k, I have created this algorithm. Now I'll quickly code it up, then we'll dry run it and talk about its time and space complexity. Okay, so this is the problem statement, and this will initially have something like a result variable, which will be storing that how many number of submatrices have their sum equal to the target. Then we can take some variables m and n, which is basically corresponding to the size of the matrix given. So I can have something like matrix dot size for the number of rows, and then n is matrix 0 dot size, which gives me the number of columns, right? After that, as I told you, the first step of my algorithm was to find the prefix sum. So in this case, what I'll do is I'll run a for loop for int I is equals to 0, I is less than m, I plus plus. Okay, so as I was saying, I plus plus, then we'll have another loop that will be for int j is equals to 1, j is less than number of columns that we have, right? So herein why have I started j from 1 is something I told you when I was making the pre-sum for the array, that we have to start from 1 if we start from 0, and we cannot have a previous column corresponding to the 0th column, right? So in this case, I'll say matrix I j plus equals to matrix I and j minus 1. What am I doing? I'm saying in the current cell, add whatever was the value of the previous cell. That means the same row but the previous column, right? After I am done with this, the next step that I had in my algorithm was to create an unordered map to store the prefix sum and its corresponding frequency, so that I can know that for any particular prefix sum, what is the corresponding frequency. That means how many number of submatrices from my given matrix have that particular prefix sum, right? So I'll quickly create an unordered map, right, which is of int type because it is storing the prefix sum and the frequency. Let's name it m. Then what I'll do is, now once I have created this, then the next step that I have is, the step 3 of my algorithm was to explore all the possible combinations, right? So combinations means all the possible submatrices that can be created from the given matrix. So I'll have a for loop for int I is equals to 0, I is less than n, I plus plus, right? Basically, these two for loops, that is for I and j, that is to have a range of columns. So I am again repeating, these two loops are for me to traverse over the different columns. That means if you initially see I is 0, so j is also 0. So you'll have a column range like 0, 0. Then j will get incremented till it is less than n. So for example, n was 3. So it will be 0, 1, right? 0, 2. Do you see the range of the columns that we are including, right? We'll talk about how we'll include the rows further. So this is for handling the combination, that means the range of the row. So see, one thing that you always need to remember is that your map will always have this combination, that is 0, comma 1. Now why is this? This is because suppose there was no matrix, right? Even in that case, the sum is 0. So there is at least one element that is present in your map, right? Then you can have something like int current, which is initialized to 0. Basically, this current is figuring out what is the current value that will be the corresponding to the indexes we are present upon. Now, we've handled in these two for loops, we have handled the ranges of the column. Now let's include how we'll be working with the row. So we'll have something like for int k is equals to 0. That means start from the 0th row till the number of rows that are present in the matrix. What you will do is you will say whatever is the current value, in that you will add matrix kj, right? So what is matrix kj? That means for jth column and kth row, you have to add that value, and you just do not have to directly add it. You need to have something like, you will basically subtract this value from matrix ki minus 1 only if the value of I is greater than 0. So we'll talk about why are we doing it. I'll be using a ternary operator. You can even write if else conditions. That's exactly how you want to write it. So basically in a ternary operator, what happens is, if this statement is true, right? In that case, this is given as the first part before the colon is given as the output. If it is false, then it is the second part is given as the output, right? So next what I'll do is I had something like a result variable initially which was declared so as to basically have the number of all the submatrices which have the sum corresponding to the target. So here I will say that the rest is also incremented. That means the rest in this case is incremented, and it is incremented only if in the given map, whatever is the current value you have obtained, if you minuses from the target that has been given and it is present in the map, right? So if this is true, right? So in this case, you can again have an if condition. I'll again be using a ternary operator. I'll say in this case, you return me whatever is the frequency at that given key of the map, or if that is not present, that means current minus target was not already there in my map, then you return me a 0. And what you will do is you will increment the occurrence of current in the map. And what finally we have to do, we'll return the result that we have initially created. I think we're good to go. Let's quickly run and see if it's working fine. Okay, yeah. So because we have used M here, we cannot use M again. So let's rewrite it to something like mappy, whatever suits you. This is the first thing that came into my head. So here I'll quickly change this. I think we're good to go. Let's see. And it is working fine. Let's submit it. And yeah, it's working fine. So let's quickly discuss the dry run for this code with respect to a problem, and then we'll talk about its time and space complexity. Okay, so this was the code that we just wrote, right? Now we'll quickly have a dry run for the given matrix that has 1, -1, -1, 1, right? And the target that has been given alongside it is 0. So basically, first the pre-sum is calculated. As I've already told you, pre-sum is basically you will be you'll be working with the j is equals to 1 column and so on, the possible columns that you have, and you will be adding whatever is the value of its previous column, right? So you will say that value of previous column plus value of current column is something that you're going to update in the given matrix. So here you were standing on matrix Ij, that is 0, 1. You will add, so here you will add this value with matrix 0, 0. So that makes it 0. Then as you've exhausted this matrix, you cannot go any further in terms of columns. You will go to the next row, and now you're standing here. You will add whatever was its previous column's value, that is -1. So that makes it 0. So finally, you will have something like 1, 0, -1, 0. Right? So after this, you'll create a mapping, right? Basically, this mapping will be storing the prefix sum and the frequency corresponding. So basically, now what we'll be doing is we'll be running this nested for loop. So I'll quickly create a tabular format so that it is easier for us to keep a track of how we are getting what we are getting, right? So initially you can see I is 0, j is equals to I, so it is 0. This is added into my map. So for key 0, I have a frequency 1, my current is 0, my k is 0. Right now these lines will be computed, that is current plus equals to matrix kj, and I'll subtract the value of matrix ki minus 1 only if I is greater than 0. But as you can see in this case, I is not greater than 0. So you will get a 0. You simply have to add the value of current with matrix kj, right? So here, once you do that, you get a 1. And now To compute the result, you'll check that is the current present in the map. As you can see, it is not present in the mapping. Therefore, you'll simply return a 0. In this next line, you will be adding the current if it is not present in the mapping. If it is present, you'll simply increment its count, right? Next, what happens is I remains same, j remains same, now k becomes 1. When k becomes 1, we already have current as 1, right? So you will add matrix kj, that is 1 0. 1 0, you get a minus 1, right? You will not be subtracting anything because I again is less than 0. So you will get a 0 now. As soon as you get a 0 for the value of current, when you be computing result, you will have something like a 1. Why? Because it was already present in my mapping. After that, once you keep doing this, your I will remain 0. Your j now will become 1 and your k, what happens is your k will be 0. Now you will see that the current has been resetted, right? And your mapping has been incremented. So this becomes 2, right? So basically what happens here now is that you will say that matrix 0, 1. So 0, 1 is 0. Nothing is subtracted because I is less than 0. It is not greater. So you get a 0. You'll check that is this present current minus target present in the map. You can see that it is with the frequency 2. You move forward, right? Then what happens is once you move forward, as we know that there is one thing that we need to always take care of. That is one thing that we missed during adding this was that we had to increment the current, right? So once we increment the current, the value of frequency becomes 4, right? So now when I is 0, j is 1 and k is also 1, then you will have the current value as 0 plus 1, 1, that is 0. Nothing gets subtracted, so you get a 0. And your resultant is 4 because the frequency corresponding to 0 in my mapping is 4. Then my j has reached its limit, k has reached its limit because m was 2 and n was 2, right? So now my I becomes 1. So my j will be 1, k will start from 0, right? So in this case, what happens is that you will have 0 minus 1, that is minus 1. And as it is not present in the mapping, the result remains as it is. And you can simply add it into the mapping. So it becomes minus 1, 1, right? Then your I remains 1, your j remains 1, k becomes 1. In this case, you will have 0 minus 1 plus 1, that is equals to 0. And here now what happens is, as you got these zeros and as I was incremented, the prefix sum frequency of 0 has become 5. So now you will get the result as 5, which is initially the answer that will be returned to you, right? I hope this is clear. The time complexity, if you closely see, these two loops have a time frequency that is om into n, right? For these three loops, it is O n into m, because what you are doing is here you are basically moving, you are taking the range of all the columns, right? And here you are dealing with the rows. So in the worst case, your time complexity is O of n into m, right? And your space complexity is O of n into m. Why do we have the space complexity? Because of the unordered map. That is basically storing the prefix sum and the frequency, right? So why is this n into m? It is because that the maximum number of distinct prefix sums can be the number of submatrices that can be produced, right? So this is the time and space complexity. If you have any doubts, please feel free to comment. Please like, share and subscribe. Thank you.